Welcome to this video on Buffered DAC using the TMS320F28379D. Today we are exploring how this powerful feature enables precise analog signal generation for a wide range of applications. So what is the Buffered DAC? A Buffered DAC or digital to analog converter module is a programmable analog module that capable of generating precise DC and AC waveforms. It plays a critical role in modern systems like waveform generation, precision control, and sensing interfacing. Let's look at some key features of the Buffered DAC. The first, it offers the 12-bit programmable resolutions that ensuring high precision in analog signal generation. The second one is it is selectable reference voltage, provides flexibility in defining output levels for different applications. Finally, the inclusion of pull-down registers ensure controlled output behavior under specific conditions. Here is an overview of the Buffered DAC architecture, and it includes three main stages. The input signal processing. This stage processes digital values loaded into the DAC registers. The second stage is the reference voltage selections. The DAC ref selection register controls the reference voltage for output scaling. The third stage is the output stage, and this stage generates the buffered analog signals that can be used by external device or systems. So how to do the Buffered DAC initializations? So let's explore the step-by-step process for initializing the Buffered DAC. The first step is enable Buffered DAC clock that activates the clock module to begin the operations. The next, set reference voltage. Configure the DAC ref using the def rec selection to select the desired reference voltage. Next, power up DAC. Enable the DAC output and wait for power up delay as per the data sheet. The last one is the managing setting times. Ensure sufficient spacing between consecutive writes. Here is the DAC register overview that control and value registers. The DAC-Val S and DAC-Val A registers. DAC-Val A holds the active value while DAC-Val S stores the shadow value for smooth updates. DAC out enable register that enables and disables the DAC output for analog signal generation. The DAC control register controls setting like sync selections and DAC reference selections for synchronization and reference voltage selections. Here is the DAC reference breakdown that configure and functionality. Here, DAC revision register. This is a 16-bit where the upper 8-bit are reserved, where the lower 8-bit are read-only bits. The next register is a DAC control configuration register that configures synchronization mode and reference voltage via sync selection and DAC reference selections. The third one is the DAC output enable that control output enable status for signal generation. Then the summary of Buffered DAC is we reviewed Buffered DAC features, block diagram, initialization process, and key registers. Further, we have seen the applications, we have discussed the real-world uses, waveform generation, and control system. Therefore, the Buffered DAC is essential for accurate and flexible analog signal generation. Now, we will see the example using the Code Composer Studio, and we will see the live demonstrations how to initialize the buffer DAC and how to change its value in the real-time interface. So now this is the Code Composer Studio, and we have implemented the DAC buffer DAC using the launchpad, that is TMS320F28379D, and we have added the DAC.c files. So to initialize the DAC, first we must know about the architecture, how the DAC architectures will be, what are the registers set to initialize the DAC. So that things we have seen in this video. Now we have to initialize it. So the launchpad is having 3 buffer DAC and all 3 are 4-bit in resolutions. So here the DAC register A, DAC control register and DAC reference selections equals to 1. We have considered, and the load mode is 0. That means that the data from the serial registers to the active register will be synchronized with the system clock, and the serial register value is 4095 by 2, and the DAC output enable we have make it 1. So we have enable it. So the same thing can be done for the DAC register B. So now we have to initialize in the main code, and in the main code after the LCD pin configurations we have initialized the DAC A and DAC B, and the prototype for this is initialized here. So now we will run and we will debug this code and we will come back to code again. So we have run and debug the code. Now we will running this code here. Now you can see that we are having the launchpad, LCD display, encoder, and the Arduino. So the encoder is setting the ref digital values to the controller, and the digital value corresponding to the analog output is seen on the LCD display, and the same analog output is seen in the PC using the gyroscope. So we have connected the Arduino, you can see that, and we will connect it over here. So it is connecting and it is giving the 2 voltages, right? Okay, so now what we will do, we will just reducing the voltage. You can see that one DAC output is increasing where other DAC output is decreasing. I am again increasing the voltage, that is 1.6. Now what we will do, we will see the voltage, what voltage is coming here. You can see that here it is 1.9 and here approximately 1.9. Now I am increasing the voltage 2.8, here approximately 2.76. So it is having better resolutions. So like this you can implement the DAC for your project. Now we are changing again to 0.9, where it is, you can see that here it is 0.9, and the other voltage is 3 minus 0.9, that is 2.1. So this is the way you can implement the buffer DAC for your projects. And if you want me to make such kind of video, comment me on the comment sections, and if you want me to teach the DSP controller, you can contact me and you can comment me on the comment section, and don't forget to like, share and subscribe the channel for the latest update. Thank you. Thank you for watching this video on Buffer DAC.